Hey guys, Professor Dustin here. In this video, I just want to give you a quick overview of what we're going to do in this section. It's called Forces, Energy, and Work, and the idea is to take what we learned in the first half of the semester, that is studying interactions via energy conservation, potential and kinetic energy, and connect it to what we've been doing in this half of the semester with forces and Newton's second law. The connection is via work, and so we've already studied work a little bit. Remember, work is the dot product of a force with a displacement. But the actual connection is going to come from the work energy theorem. So work energy theorem says the change in kinetic energy is equal to the work done. Since the work is related to the force, this is actually our connection between energy and forces. So a couple things we want to do with this. So far we've only considered constant forces. For instance, the force of gravity is a constant force mg. If you take a constant force dotted with a position vector, as the force moves, we can just dot it with the position vector, we have no problem. But what if this force depends on the position? Then which position do you evaluate the force at? So this is a typical calculus problem, so we're going to need to use a little bit of calculus to work out forces which depend on position. The other thing we want to do is, there are a few cases in the energy section where we couldn't use conservation of energy. Specifically when we had non-conservative forces like friction. We don't know how to include friction into our energy equations. Well, because we can always find the work done by a force, even a non-conservative force like friction, we can find the change in kinetic energy, and we can include friction into our considerations of energy. So we're going to talk about conservative and non-conservative forces and how we can use either energy or forces to solve nearly any problem that we encounter in physics.